Hello everyone, welcome to Learning by Solving YouTube channel. This is question number 8 of GATE 2021 Electronics and Communication Engineering. So this is one mark question. Let's try to solve this question. In the circuit shown in the figure, the transistors M1 and M2 are operated in saturation. Is given that both the transistors are operating in saturation region, and the channel length modulation coefficients of both the transistors are non-zero, and the transconductance of MOSFETs M1 and M2 are given as ZM1 and ZM2 respectively, and the internal resistance of the MOSFETs M1 and M2 are R01 and R02 respectively. So ignoring the body effect, the AC small signal voltage gain of the circuit is what is asking. So let's try to zoom it out once. So he's asking the voltage gain considering the internal resistances and the transconductances. So let's try to find out this voltage gain here. When you look at this amplifier, since it is one mark question, so we need to do it by the observation. So when you observe here, so this can be written effectively as 1 by ZM1 parallel with R01, 1 by ZM1 parallel with R01. And if it is given in terms of p type MOSFET, it is better to convert into n type MOSFET, since the voltage gain for the both MOSFETs, whether it is p type or n type, it is almost the same. So let's try to do that. So since it is the DC source, for calculation of the voltage gain, it should be grounded. So once you do that and simplify, let's try to convert it into the n type MOSFET. So let's do that here. So let's take the n type MOSFET here. So this is n type MOSFET, and here we have given voltage, input voltage to the gate terminal. So let's give the voltage here for the gate terminal, and the source terminal is grounded here. So this is grounded here, so let's do that ground here. And for the drain terminal, it is effective resistance is 1 by ZM1 parallel with R01. So let's try to give that information here itself, that is 1 by ZM1, and this is parallel with R01. So this is the resistance here. So, and this drain terminal is also grounded after this resistance, and output is taken here. So we need to take the output here. So this is common source amplifier. Whenever the common source amplifier is given, that how we are saying this is common source, because for the gate terminal we are giving input, and at the drain terminal we are taking output, and the source terminal is grounded. So this is common source amplifier. For the common source amplifier, the voltage gain is always negative. So let's try to find the simplification voltage gain of this simplified n type MOSFET here. So that is AV is equal to minus of what is the numerator term we need to write. So we have to observe the voltage. We are taking the output here, right? So go here up to the ground, and go here up to the ground, and figure out the effective resistance here. That is nothing but this upper resistance and the lower resistance are in parallel. So now it becomes 1 by ZM1, and that is parallel with R01, and that is parallel with here he also given R02. So this is parallel with R02. So this is the numerator term. And what is the denominator term? For the denominator term, we have to go from the ground to the input and see what is the effective resistance when you look from here. So effective resistance when you look the source of a MOSFET is nothing but 1 by ZM. So here it is transistor 2, it is ZM2. So when you simplify this, what the voltage gain that you are going to get, that is minus ZM2 into 1 by ZM1, 1 by ZM1 parallel with R01, and which is parallel with R01, and this is again parallel with R02. This is the voltage gain of the given MOSFET. So let's see what is the answer for this question. So here the answer is option D, that is minus ZM2 into 1 by ZM1 parallel with R01 parallel with R02. So option D is the correct option for this question. So let's quickly summarize what we have done here. So he actually gave one transistor which is a p-type semiconductor p-type MOSFET actually given. So we converted, we simplified, we used two simplifications here. One is this one, that is 1 by ZM1 parallel with R01. We have written this because the drain terminal and the gate terminal are grounded. Whenever we find the MOSFET in this fashion, we can write it is in terms of resistance as 1 by ZM1 parallel with R01. And since it is given the p-type MOSFET, it is better to convert into the n-type MOSFET for the simplicity for the calculation. So that we have done here. And wherever the input is there for this MOSFET, same place we have given input and the output, and we find out by the inspection that what is the voltage gain, and that comes out to be as minus GM2 into 1 by ZM1 parallel with R01 and R02. Since it is common source amplifier, the voltage gain is always negative. So thus we got the voltage gain, and option D is the correct answer for this question. Thank you so much for watching.